Welcome to section 21.1b. Alright, gentle people, what we talked about in the last lecture was we said that we have our alkanes, and our alkanes can be straight chained or branch chained alkanes. Now, if you take a look at these two formulas that I've shown you here, what you'll notice is the formula is the same for both compounds, C4H10. So what I have here are isomers of each other. One where you have all the carbons in a line, and the other one where you have a main chain and a branch going off. So we have to go ahead and figure out how to differentiate between these two when we start to name these compounds. Because remember, as I showed you in the last lecture, both of these have different boiling points, and there are other properties that differ between these two compounds. Now, in order to name an organic compound, you're going to follow this basic idea. And that is, you're going to figure out what the parent molecule is, and it goes on the end of the name. Then what you're going to do is you're going to figure out what the substituents are on that parent molecule. Now, a substituent is that side chain or that branching off portion of the molecule. It is something other than hydrogen that is attached to that parent molecule. Now, once you've identified the substituents, what you have to do is tell me where it is, or the locant of where that substituent resides. So let's take a look at the rules for naming an alkane. So remember, an alkane is just made out of hydrogens and carbons. If that's the case, the parent molecule is going to be the longest chain of carbons. And that means the longest continuous chain of carbons. Now, once you identify that longest chain, you're going to count the carbons, use the appropriate prefix for that count, and then you're going to stick A and E on the end. So, for example, let's take a look at that branched alkane we were talking about. What you guys will see is that there is 3 carbons in a row, 1, 2, and 3, and this other carbon is not in that continuous chain, it is branching off. So since there are 3 carbons, prop, and then A and E to signify it's an alkane, so the parent molecule here is propane. So why don't you guys take a look at this molecule right here and tell me what is the parent molecule? Okay, what some of you might have done is you might have looked at this from left to right and said this is 1, 2, 3, 4, and 5. Now, I want you guys to be real careful. Sometimes the way that they depict organic molecules is such that they can fit the organic molecule on the page or to highlight some part of the structure. So it is not like reading a book. In this case, the longest chain of carbons is actually, if you stop here, you follow the carbon chain and take this bend and wrap around. If you do this, the longest chain of carbons that you can make are 6 carbons, so hex, and it's only made out of carbons and hydrogens, so hexane. That would be the parent molecule's name. Now, once you've identified the longest chain, you guys are going to look for branch points. Remember, these branching portions are what we call substituents. So the first thing we got to do is we got to name our substituents. Most of the substituents I'm going to give you are alkanes, meaning the branch is only going to be made out of carbons and hydrogens. To name the substituent, what you guys are going to do is count the number of carbons and use those same prefixes for carbon counts. Then what you're going to do is you're going to use the suffix YL to denote that it is a substituent, that it is something that is branching off the main chain. So in this case, we have a substituent made out of 1 carbon. Methyl would be the substituent's name. And again, the same right here. 1 carbon, meth, because it's a substituent, ill, so methyl as my substituent. So in this case, what you guys will see is we have our main parent molecule being 6 carbons long. There are 2 substituents or 2 branches. Each branch is made out of 1 carbon. So that means it is meth and then ill because it is a substituent. Since there are two of these, I'm going to denote that there are two branches with one carbon. I'm going to put a di in front of it, saying that there are two methyl substituent. Here's one substituent that's a methyl, and here's my second substituent that's a methyl. So dimethyl. The next thing you got to do is you got to tell me the locant, or where these substituents are residing. To do this, we are going to count our carbon chain. And again, we're going to fight our instincts by always thinking of these things from left to right. What you're going to do is look at your parent molecule and then decide what will give you the lowest number when I describe where that substituent is. For example, I could have numbered this carbon chain from left to right. If I did this, the locant of the first methyl, this one right here, would appear on carbon number 3. And the locant of the second methyl group would appear on carbon number 5. Now, what you want to do when you number carbons is you want to lower the numbers as much as possible. In this case, if I had numbered in what I've displayed in red, so this numbering scheme right here, what you can see is the locant of the first methyl is 2, and the locant of the second methyl is 4. Since 2 and 4 are lower than 3 and 5, this is the preferred way to number this carbon chain. And so now I can name this compound 2,4-dimethylhexane. To drive home this point of numbering carbons, what I want you guys to remember is this kind of rule of thumb, and that is the first point of difference. What you want to always do is make your priority group always the lowest number, and then what you want to do is you want to try to lower the numbers on the substituents such that if there are two ways to number it, the first point where they differ is what is going to help you decide which numbering scheme to use. You're always going to use the one that gives you the lowest number. Let's take a look at some examples. So if we take a look at this molecule up on top, you'll see that the longest chain of carbons is 8 carbons long. What you can see is I've numbered the carbons in two different ways. There's the top way in green, going from left to right, and then there's the purple way going from right to left. Now I have 3 substituents here. Here are my 3 methyl substituents, and now I'm going to tell you the locant or the location of them. If I use the green numbering scheme, what you will see is the locations of those substituents are 4, 5, and 7. And so I could say this is 4,5,7-trimethyl. Now if I use the other numbering scheme, 2, 4, and 5. Now that could also be called the 2,4,5-trimethyl sequence. Now what I want to do is look at the first point of difference. So if I look at these numberings, 2 versus 4, here's the first numbers appear, I notice a difference. 2 is lower than 4. Now that is the preferred numbering scheme. Let's take a look at another example here on the bottom. Again, we have this long chain of carbons right here, and that's going to be our octane. And then we have 5 methyl substituents on here. 1, 2, 3, 4, 5. And now what we can do is we can try to number this carbon chain. And so here's the 2 ways that we can number it, left to right and then right to left. And these are the locants of where those substituents appear. Now what you guys will notice is we'll go down the list. 2 and 2, there is no difference. So this doesn't tell me which sequence is preferred. But then the second number, 2 and 3, well now I have a difference. 2 is lower than 3, so that is going to be the preferred numbering scheme. So let's take a look at some other things that you might come across. So again, here's my organic molecule. Here's my longest carbon chain. And what you guys will see here is that we can go ahead and pick our numbering scheme. 1, then 2 is going to be preferred rather than 1, 2, 3, and 4, 5. So I'm going to go ahead and number this carbon chain from left to right, 1 through 8. Now what you guys will see is I have 3 substituents, a methyl substituent, a methyl substituent, and this substituent is 2 carbons long. So that means F and then il for it being a substituent. And so when I go ahead and name this, what I'm going to do is I'm going to place the locant in front of each one of my substituents. I'm going to make sure that I count the number of substituents of the similar type. So dimethyl here. And then when I put the name together, what I'm going to do is I'm going to present each substituent in alphabetical order. So what you guys will notice is that ethyl comes before methyl, or E comes before M. Do not count the tri-dis and tetras in front of things. Count the substituent or the carbon count itself. Now, another thing you can run into is what happens if you have a tie. So for example, let's go ahead and notice that this is our longest carbon chain, and let's go ahead and start to number from right to left. 1, 2, 3, 4, 5, and 6. If I go ahead and look at where my first substituent appears, if I'm going on the bottom numbering scheme, it appears on carbon number 3, but then if I go from this other numbering scheme, it also appears on carbon 3. So it seems like it doesn't matter which way I numbered my carbon chain. However, you'll notice the substituents are different. One is I have an ethyl and the other is a methyl. So if you have a tie, what you can look at is the substituent itself. If there is a difference in substituents, what you want to do is the one that comes first in alphabetical order takes preference, and you want to make sure that it has the lowest number. So in this case, ethyl comes before methyl, so that means I want to put the 3 on the ethyl instead of the methyl. So with all of that said, let's go ahead and take a quiz and practice this out. So given this structure here, please give me the official name of this compound. Alright, the first thing you want to do is identify that parent molecule. And remember, the parent molecule is the longest chain. So this right here is the longest chain. It is 1, 2, 3, 4, 5, 6, 7 carbons long. Now, what you guys should note is that you could have gone ahead and numbered it 1, 2, 3, 4, and you could have gone 5, 6, and 7 and gotten a similar chain written out here. So it doesn't matter which chain you pick. If there's a tie, just choose one of the longest chains in there. To make life easier, I'm just going to choose my original boxed one. Now what I have to do is I have to go ahead and number my carbons. And so what I want to do is look at where my substituents appear. So I can number it 1, 2. That gets me the first substituent on carbon number 2. I can start numbering it the other way. 1, 2, 3, 4. And so in this case, that gets me the first substituent on number 4. So in this case, I want to go ahead and label my carbons from left to right. So here's my numbering all laid out for you. I have a substituent here, and I have another substituent right here. So let's go ahead and label these substituents. So my first substituent, this one right here, this is only made out of 1 carbon, so that is going to be methyl. My second substituent is made out of 3 carbons, so that's going to be propyl. So remember, my parent molecule was made out of 7 carbons, so that means it's going to be heptane. We already figured out our numbering scheme, and so the methyl appears on the 2 position, and the propyl appears on the 4th position. So now what I can do is string all of these together. So remember, heptane is the parent, so it gets on the end, and then I list the substituents before it. Since M comes before P, I'm going to put the 2-methyl in front of the 4-propyl. So this would be the correct IUPAC name. Now you guys can see that using the rules that I've showed you, we get some real cumbersome naming. And so there are a few common names that come into play that I want you guys to know. And these are really used for things where I have branches on my branches itself. So these 4 substituents is something that I want you guys to memorize. But let's go ahead and take a closer look at them. Okay, ladies and gentlemen, let's go ahead and draw a really long carbon chain. And what I'm going to do is I'm going to put substituents on here. So the first substituent I'm going to do is going to be 3 carbons long. And you've seen this substituent before. I'm going to attach it on the end, and I'm going to put 3 carbons in a row. And so here's my attachment point, and then this right here is my substituent. And you would normally call this a propyl substituent, and that's its official name. That is a propyl group on there. Now what you'll notice is where I attach that propyl group. I'm attaching it to one of the end carbons. Now let's go ahead and put one of those substituents on that slide that I was talking about. Now this substituent is still going to be 3 carbons long, but what you will notice is I don't attach it onto the end carbon. I attach it to the middle carbon in my propyl group. Now when I do this, I'm going to go ahead and call this an isopropyl group. And again, to show you, that's just to differentiate where that propyl group is attaching. All right, let's take a look at substituents that are 4 carbons long. So if I put 4 carbons as my substituent, this is what you guys have seen before. This is where it is attached to that first carbon or one of those end carbons as my substituent. So again, everything above the blue line is the substituent. So what I can do, instead of attaching to that first carbon, I can attach it to the second carbon. So 1, 2, 3, and 4. And you'll notice the attachment of my substituent is to that second carbon right here. So this one is called sec-butyl. The sec stands for the second carbon in that butyl group. So I hope you guys can see the difference between these 2 substituents. Again, they're both 4 carbons long, but I'm attaching it at a different place. Now, another way that I can have 4 carbons attach, 1, 2, 3, instead of a straight line, I can have the substituent form another branch. So again, we have 4 carbons. I'm still attaching it to the end, but now instead of all 4 carbons being in a line, what we have is they branch later down the line. This is what we call an isobutyl group. Iso means same, and what you guys will see is it has the same end on this group. Now, the last common substituent that I want you guys to know is still a butyl group, and this happens when my carbon that attaches to the main chain radiates out 3 carbons. So here's carbon 1, 2, 3, and 4. Now what you guys will see is this makes kind of a little T, and so this is called tert-butyl. Sometimes they shorten it to T-butyl, but this is going to be my tert-butyl substituent. And again, you guys can see the difference from a normal butyl substituent. So if your substituent is a branching substituent, here are the common names that I want you guys to use. Some things to note is that when you guys put this in alphabetical order, the ones with dashes, you do not consider those prefixes in front. So sec-butyl, you want to alphabetize it based off the B, And tert-butyl, you want to alphabetize it based off the B as well. For the ones that are iso, you are going to count the I. So the I counts in these ones. All right, Chem 1C, I hope that made sense, and remember to stay safe.